The Turkey Marathon. Okay, welcome back, class. I'm Mr. Teacher with the SAT Math Video Guide. Indeed, marathon for Thanksgiving. It shall run from Thanksgiving, which is today itself, and move on to maybe Saturday or Sunday, where I'll try to post much more than normal. And so, last time we left off on number 11 of section 5, test number 2. So, we're gonna just get started. So, number 11 says, the inside dimensions of the rectangular box shown above are 4 inches by 4 inches by 8 inches. What is the maximum number of CD cases like the one shown that will fit inside the box if each CD case has outside dimensions of 4 inches by 4 inches by 1/4 inch? So, let's start labeling this diagram. So the box is 4 by 4 by 8, yes. And the CD case is 4 by 4 by 1/4. These are all in inches. And if you hear some background noise, I apologize. There might be something wrong with the mic, which I have checked on for multiple times. Haven't found the problem yet. But, yeah, so now, first things first, it doesn't have to be in any order. So let me explain. Like, in the box here, the length is 4, the height is 4, and the width is 8. But it can be any other way. That's not really going to factor what's going on in the math problem itself. You just need to remember to keep it likewise with the CD case. So how many CDs can fit into this box? Well, we know the CD is 4 by 4. We know the box is 4 by 4, so we have that covered. It's going to fit perfectly. And so for every 1/4 inch in the box, there is going to be one CD case. So what we need to do, since there's 8 inches of width in the box, we need to divide 8 by the width of the CD case, which is 1/4. And when you divide with fractions, you just need to move this over here, and you reciprocate it, and then you multiply. So in reality, this is 8 times 4, which is equal to 32. So 32 CD cases can fit inside the box. That is your answer. And now we'll move on to number 12, which is right over here. So number 12 says, if 3x plus y divided by y is equal to 6 over 5, then what is the value of x over y? Well, for this, it's just really an equation. It's just algebra. So we're going to start solving this equation over here. So 3x plus y divided by y equals 6 over 5. So what we need to do is get rid of the denominators, so we can actually solve it like a proper equation. So we multiply 5 on this side and on this side, so that cancels out the 5, and we multiply y on that side and on this side, so it cancels out the y. So what happens if we multiply 5 to the left hand side, it becomes 5 times, that's a horrible 5. I'm surprised. Okay, 5 times 3x plus y is equal to, and the y goes on the right side, so 6y. Then we distribute the 5 over both terms, so 15x plus 5y is equal to 6y. And then we subtract, oh, that's not it, 6y. And then we subtract the 5y on both sides to get 15x is equal to y. Well, now we need to find x divided by y. So let's just find out what 15 equals to. And it might be a little confusing because generally you have to find what x is, and you would divide the 15, but excuse me. But you can do it the other way around. If you want to find out what 15 is, then you divide the x on this side. So 15 is equal to y over x. And to make this x over y, you just reciprocate both sides. So x over y is going to be equal to 1 over 15. Why? Because 15 is really 15 over 1. So that's your answer, 1 over 15. So now we'll go to number 13. And I hope you watch the video, even though it's Thanksgiving, but of course these videos aren't going anywhere. You could watch it later. So there's a table here, and we'll attempt to draw it like so. There we go. Year 1, year 2. I should have foreseen this. Store A, store B, store C, and total. Can do better. Total. Store A, store B, store C, total. And we still don't know what's going on. I'm just drawing it for you guys. So year 1s are 5,000, 6,000, and 10,000. Total is 21,000. Total on this one is 26,250 on year 2. Total in store C is 12,700. That's a lot. 7,350 and 6,200. So lots of figures involved. So now the table above lists the profits of 3 stores in 2 consecutive years. So what was the average increase in profit? Average increase in profit in dollars from these 3 stores from year 1 to year 2. So we need to find the average of the total profits, total increase in profit. So we already have the total. Cross these out. I'm telling you now, cross these out, because you're not going to need them. When you turn them into the average, it's the same thing. Like, to find the average profit of year 1, you would add 5,000 with 6,000 and 10,000 and divide it by 3. And what you could really just do is divide 21,000 by 3, and you'll still get the same thing. So we're going to do that. So year 1, average profit, let's make a second part of it. Average profit will equal 21,000 divided by 3, which is, I believe, 7,000. And correct me if I'm wrong. Well, nobody's going to see this while I'm making the video. 26,250 divided by 3, which we're going to do on this side really quickly. And 26 goes 8 times, 24... 22 goes 7 times, 21. Oh, we're running out of space. 15 goes in 5 and 0. So 8,750. Now, to find the average increase in profit, what you have to do is just subtract these. So 8,750 minus 7,000. Because these are the profits, and we need to find the average increase in profit, and then you get 1,750. And that's your answer, right there. Okay, so now we will move on to number... Oh, I blanked out there. We'll be moving on to number 14. And in pink, oh, very bright color, I would say, there's an equation here. F of x is equal to the absolute value of 3x minus 17. Alright, so for the function defined above, what is one possible value of a for which f of a is, oh, no, not greater, less than a itself? So what is all of this confusing stuff? If we take the f of x equation again, if you remember from a previous video, what this really is, this is the x value, and this entire thing is the y value. So f of a is simply the y value, a is the x value. X value is the one you plug into the equation, y value is the output that you get. So algebraically, this is a little bit of a pain, because there are long equations involved, but I will still show them, because there's 2 methods. One is guessing, and guessing I think is the last resort. Not in this case, but we still need to do it mathematically. So since it's absolute value problem, what we need to do is we're going to plug in a into x. So 3a minus 17 must be less than a because this is the equation from which we will get the result, and it must be less than a itself, or because it's an absolute value, negative 3a minus 17 is less than a. Now we need to solve both of these. Let's start with the top one. When we solve the top one, then we will get, when we subtract the a on the left side, we will get 2a is less than, then we add the 17 to the other side, 2a is less than 17. Then we find out that a is less than 17 divided by 2, which is also 8.5. I believe. Hopefully. Yeah, it is. Okay. So the next equation, which is negative signs, when we distribute the negative sign to both parts of the equation, not the right side, I mean this part. So in negative 3a minus minus is a plus, so plus 17 is less than a. Then you get minus 4a is less than minus 17 after subtracting the 17 on both sides. And then you just make these into plus signs, because that's basically the same thing. Did I do that right? No, then you also need to switch the sign. My apologies. That's what you do when you switch the entire sign. So 4a must be greater than 17, and a is greater than 17 divided by 4, which is 17, 18, 19, 20, 17, so 1/4, 4.25. So a is less than 8.5 and is greater than 4.25. And it's a little long, but like I said, there's another way, which is just guessing. And in this case, it might be considered a great way to solve this problem, because a lot of people have trouble with absolute values, including me. I used to have a lot of trouble with these. And yeah, so we'll move on to number 15. Let me finish it up. So, from a jar containing 50 pieces of candy, of which 25 are red and 25 are green, Ari has taken 3 red and 4 green pieces. He takes an additional 13 pieces from the jar. What is the least number of these additional pieces that must be red in order for Ari to have more red candies than green candies among all the pieces he has taken? So, Ari, at the moment, has 3 red. Actually, let's visualize that. Ari has 3 red, and the other color is green, so he has 4 green pieces of candy. So he's going to add 13 more candies to that. And I can tell you now that when they said the jar contains 50 pieces of candy, of which 25 are red and 25 are green, you don't need that at all, because this is all the information that you're going to need for this problem. So Ari wants to have to have more red candies than green candies. So we need to divide up the 13 into such a possibility that there are enough reds to make it so that he has more reds than greens. That was an awkward point in my sentence. So what are the splits possible? There's 7 and 6. Now what happens if it's 7 and 6? Well, 7 plus 3 is 10 red, and 6 plus 4 is also 10 green. It's still 10. So we know that 7-6 split isn't going to work out. So let's add one more to red. Then obviously it's going to work out, and we need to change this to 5. And then what we will get is 8 plus 3 is going to equal to 11 red, and 5 plus 4 is going to equal to 9 green. So in that case, he has more red candies than green, so he must have, what is the least number of these additional pieces that must be red? the least number of additional pieces is 8. Of course, he can pick out more red candies, but that's the least. So that is enough. That's about all the time I have for this video. I think we achieved much more than we usually do, 5 problems. But next video I will finish this up, and watch out for the Thanksgiving special, which is just a little compilation that I have. I don't know why I'm gonna put that mess up on camera, but I guess it adds as a joke. So stay tuned for that, and I will see you very quickly in the next video. Let me just get started on that. So yeah, number 16 in the next video.